Okay, so welcome to this Techability webinar on understanding computer specifications for assistive technology. It's the kind of level that it is. It's going to be at quite a basic level. We're going to understand just what are the main computer components, talk a little bit about the important features, and we're going to learn how to match these up to the software specifications that we get. So I wanted to start with an example that I found online, and it was from a DSA recommendation, so disability support allowance, and they've been offered Dragon, Glean, and Inspiration. They said, I'm wary about slowing my laptop by downloading so much software onto it. I like it to run fast. So this might be an example of the kind of thing that we might be approaching. Someone who wants some software and wants to match up the specifications to those. So just from a little bit of Googling, you can find out the specs for these. So it's just a case of typing in this case, Dragon Professional version number you've got and specs or specifications. And they give a minimum. So they say for RAM, the minimum is 4 GB for all operating systems. The CPU, a minimum of 2.2 gigahertz, and then they go into more detail of what type of processor it is, and the free hard disk space, 12 gig. That's interesting when you compare it to what the spec of the next one for Glean, because they give both a minimum and also a recommended. So the minimum of 4 gig of RAM, recommended of 8 gig of RAM, and then again they do different for the processor. And then rather than saying the hard disk space usage, they talk about how much per hour of recording it takes to record a gigabyte of storage. So you can see the specs are a little bit different on there. And if we just go back to Dragon, if we use the 4 gigabyte minimum that they're talking about, there's likely to be a delay, and a delay might mean that a student says something with Dragon and then there's a delay until the words appear on the screen, meaning that they'll say it again and then they'll make a mistake and then they'll have to correct the mistake. So you can see how even sometimes the minimum might make the software unusable realistically for some of our students. So just bear that in mind, that there's a minimum, but then it's good to kind of look for the recommended. So with Dragon, even though they're saying 4 gig of RAM, I'd probably double that and go at 8 gig. And I'd be trying to look a bit above the processor speed that they're looking at there. Those are the main things that will affect the speed. Then we've got Inspiration, which again have written their specs up a little bit differently. They're just saying that it consumes a low processor and memory when running, has a small hard drive storage footprint, so 227 meg, and it's 1,000 meg to a gig, so that's really small actually. And they're saying that if the device can run Windows successfully, Inspiration 10 will be fine to run on the device. So that makes it a bit more simple in terms of specs. So as you can see, different ways of showing specs. You just have to use your common sense sometimes a little bit to work those out. Now we're going to look at what those actually mean. So there's individual components. When we're looking at a computer, these are the main components. You've got RAM, CPU, storage, the graphics card, and the motherboard. The one that we're not going to talk much about today is the motherboard. Really, for the sake of what we're covering today, you just need to know that it's the main board that everything else fits into. And so it won't come up very often when we're looking at specs. That's why we're not going to be covering it much today. So memory-wise, there's two different types of memory, and this is often one that people can get quite confused with. So we're looking at RAM versus storage. So the way to think about it is RAM is short-term memory. So it's a kind of working memory for the computer. It's what the processor uses to process things. And then storage is long-term. So that'll be where the system is, and it's where all your files will be as well. And we've got an example specification of a computer on the right-hand side. So what we're looking at there, the RAM is 8 gigabytes, and the storage is 256 gigabytes. So RAM will affect the speed, and storage is where we can store all our files and the system. Let me know if any of this doesn't make sense as we go along, or if you've got any questions, by the way. Okay, so with that in mind, RAM for working memory, some rough figures are 4 gigabytes to 8 gigabytes are good for general use. So 8 gigabytes would be the kind of higher end of general use. 4 gigabytes would be quite low. If you've got larger kind of data processing, you'd be looking maybe 16 gigabyte upwards, and 32 gigabytes would be very high-end graphics. So that'll give you a kind of idea of the kind of scale that we're looking at. Something to think about with RAM is that it's worth looking at it if it's upgradable. So that means either the motherboard that we were talking about earlier will have an empty slot there, or it means that you can replace the current RAM stick with a new one. And to do that, it can't be soldered or attached to the motherboard. So on the top one, there's a picture of the RAM that's soldered onto the board. As you can see, you wouldn't be able to remove those 4 black little items there and replace them without soldering and without some real skill. Whereas the next one down, that's actually able to be just clipped out and clipped in again. So that means it's upgradable. And that's one of the first things you'd learn if you were looking at doing some things with PCs yourself, because swapping RAM is quite straightforward. But you have to beware of static and also avoiding the warranty. So I don't want anyone today taking apart a computer that's managed by your IT team or anything like that. Please don't do that and get me into trouble. Storage wise then, so this is where all your files and the operating system are stored. You've got different types of disk. So the one on the left is the oldest one. These are quite heavy, and there's actually a physical disk inside it that spins. That's why on those computers you'll hear a kind of whirring noise when you fire them up. So it's a HDD, which is a hard disk drive. They're quite old and heavy, and they're sensitive to movement. So it used to be if you dropped or shook it or something like that, you might affect the disk itself. The newer ones, so if we go to the middle, we've got a solid state drive there. So it's newer technology that doesn't rely on a disk. So there's no moving components in these anymore. So they're newer, they're lighter, and they're not sensitive to movement. And they're much, if you hold them in your hand, they're much lighter than the old hard disk drives. And it's for the size that you get a lot more storage generally as well. You've then, on the right-hand side, you've got a newer version of the solid state driver, which is helpfully called M.2 NVMe. Don't expect you to remember that. I know I can't. They did so well with the naming conventions there, didn't they, until they hit this point. But it's still a solid state driver. It's the newest and the lightest, and it's really good for laptops because obviously trying to save room in the case, and you're trying to make it as fast as possible. So again, it's not sensitive to movement. So in practice, what that means is that it's very rare that you'd get a hard disk drive on the left-hand side now in a newer laptop or computer. You just wouldn't have that. But if you're buying secondhand or advising students on buying something secondhand, that might come up, and it's probably worth avoiding as it's quite old technology now. So then really your choice often will be between the SSDs and the M2 NVMEs. And they're both pretty good. They're both pretty fast. But the one on the right, the M2 NVMe, is the newest. It's the lightest. It's the better technology. Often you'll find that you might get 2 hard drives as well. One might be for the system itself for Windows, and then another one for storage. So often they'll use the one on the right as for the system for Windows to run really fast, and then for storage to be a bit slower, pair it with a solid state drive. In terms of storage amounts, there's rough figures of 250 gig to 500 gig. It's probably a minimum that you want. I know that I think mine's only 250 gig, and I need to upgrade it on this laptop. And the effect is that as you start to fill it up, if you fill it up too much and you're right on the edge there, your whole system will start to slow down because it's got less room to work with. So an average you'd be looking at is 1 terabyte. If you want to work with kind of high-end graphical kind of kind of programs or games and things like that, you're probably looking at 2 terabytes upwards. And just underneath there, I've just put how much. So a terabyte is worth 1,000 gigabytes. A gigabyte is worth 1,000 megabytes. So with the storage, there's some considerations. Again, is it upgradable? Do you have a second slot there that you can swap that over? It's quite easy to swap and add a hard drive. Often it is just a case of pulling something out, putting something in, that kind of thing. But if you pulled out the one with your whole system and things like that, you'd then have to reinstall Windows. You'd have to restore all your files and settings because all of them are stored on that hard drive. So when you're buying things, the thing to consider is it's generally lower cost than other components. So it often doesn't cost much to upgrade to a higher disk. Yeah. And consider the weight as well when you're buying it. Now, the processor and CPU is often referred to as the engine of the computer or the brains of the computer. It's where all the processing happens. So everything that's worked out and put onto your screen goes through the processor in some kind of way. There's 3 main specifications that you need to look at. The one is frequency, how fast. Another is cores. So there's more processing at the same time, the more cores that you've got. And then age, I'd say, is also really important. So newer equals better. It's very hard to be able to tell the difference between processors on the surface. On the right-hand side there, you've got Intel Core i7. You've got a serial number i7-6700K. Some more numbers. You've got that it's 4 gigahertz. That's the speed, frequency, how fast. But then we can't really tell from that how many cores, and we can't really tell from that directly how old it is. So I'm going to say the best way to do this is to use a tool that will tell you what is better, what is faster for you. So we've got an example here. We've got the Intel Core i3-9100F. Again, excellent naming conventions. And on the other side, the Intel Core 2 Quad Q9400. And it'd be quite easy to think that, well, maybe the one on the right-hand side is faster because it looks like it's got better branding. It's the Core 2, it's a quad. But we can find out. So I've put the link in here. I'll also put it into the chat so you can use it. And I'll share my screen to show what it looks like. Okay, so it's a completely free website, and it's pretty useful. So if I was just searching between two of the options, I can type in i3-9100F, which was the first one. Let's see if we can find that from that. Yeah, there we go. That's the one, Intel Core i3-900. What I do is I just tick that one, and then we'll look at the second one, which is the Quad Q. You can put the full name in here. I'm just not doing it because it's easier not to. 9400, and search for that one as well. And then I'll tick that one. And then once you tick those two, it will take you to a comparison there of the 2 processors. So there's a lot of information on the page there, but there's some things that I'm looking for in particular. So if I go down here, there's 2 charts. I'll just zoom in a little bit on this. And it'll give you the speed rank out of all the processors that they've got. So on the left-hand side, we've got this is 233rd out of 1,439, whereas the one on the right is quite a lot lower down there. So it's almost 900th place there. And then underneath it will also give you an idea of how good it would be for gaming, a desktop or a workstation. And it'll give you some kind of percentage scores there. And then if I just go underneath that, the effective speed, it'll give you a much faster effective speed on the left-hand side, plus 74%. Okay, so that's a good way of comparing processors. It's what I do. You often can't tell exactly from the processors themselves, and the difference here really has been the year. So the one on the left was released in 2019, whereas the one on the right is 2013. So you've got 6 years of kind of technical advances between those two. There we go. So those are the two processors that we compared, but obviously you can compare different ones, or you can just type in one and then click on it and have a look at that processor itself to find out how fast it is. So let's have a look at graphics cards a little bit. Now, you might not need much in the way of graphics. They're mostly useful for video editing and gaming. Anything that focuses on the visuals in your computer will focus on that. Sometimes they're part of your processor itself, so you can have what's called onboard graphics with your processor. Onboard graphics with either your processor or on your board are likely to be slower than a specific graphics card. If you're looking at a gaming PC, this would be one of the key things that you're looking at. But if you're just looking at a workstation, then it's less important. And again, I've put the link under there. The same website also that I showed you before also focuses on graphics cards, so you can check those there. I'm not going to cover those much now because in terms of assistive technology, there's not much that needs graphics and that side of things. It's more if you had a student who was using a computer to do gaming as well as assistive technology. So there are some other features to consider. One of the key ones is the Windows version. If you've got a modern version of Windows, it's going to be updated for much longer. It's going to be secure. If you're looking at older versions of Windows, you might not be secure, and it might not be updated as well. You need to look at how many USB slots you've got. If you're looking at plugging in a mouse, a headset, maybe a separate keyboard, maybe a separate webcam, things like that, they can soon add up quite a lot. So you're always worth future-proofing it by getting more USB slots than less. And also thinking of things like pen drives and storage as well. Webcam, need to consider how good a quality it is. Does it have one of those features where you can cover the webcam as well? Or do you just go low tech and put some blue tack on it? Need to consider the position of the power button and how easy it is to access for some students with physical disabilities. Battery life is key if they're going to be using it out and about and in different places. The keyboard, you want something that is going to be legible, so able to be read by the student. So maybe they want lowercase, uppercase. They might want on some gaming kind of laptops, you get different color backgrounds and things like that with the keys. But they're designed to be quite compact, so it's worth considering plugging in an external keyboard in terms of accessibility. There is also considerations around the touchpad itself. We've got some different touchpads on the right-hand side. Some of them are quite large, some of them are quite small. Some of them have the buttons built in. So it's always worth having to think about the access in terms of that. The screen size is important. Sometimes bigger isn't always better. If you're looking at 17 inches, 19, is probably a kind of average. But then for some students, they might have a limited visual range. So actually a 15-inch screen or something quite small might be better for their focus and for their concentration. You can also have, obviously with HDMI, you can connect to external screens, which can be much better as well. And the quality is quite important sometimes as well. Especially some laptops have quite low ability to be seen in the dark. sorry, in the bright. So if you're outside or something like that, or in direct sunlight through a window, sometimes the brightness might not be enough to be able to see the contrast on the screen. And the weight is important. You want to be thinking about if the student's taking it around either in a backpack or a laptop case, is it going to be quite heavy and hard for them to carry around? Warranty is really important as well. If you're looking at having things covered and that security, I think the value of if this breaks, how we're going to replace it, how we're going to repair it, and what's the kind of end of life plan with the device that you're using. So today it's just a very basic guide. If wherever possible, use IT support. IT professionals go through some, a lot more qualifications. They understand about the infrastructure that your college or organization uses. The reason that today's webinar is here is because not everyone has IT support at times they need it. And sometimes we'll be asked to give recommendations for a student, and IT teams are busy and things like that. And also it's useful for us to have this kind of background knowledge so that when we're looking at making recommendations and passing things for our IT team, at least we've got some kind of base knowledge of what we're looking at there. And maybe you are the IT support, in which case, hopefully this has been helpful for you to kind of see some of the specs of some of the software that we're using. Obviously, there's different specs for different software, so you'll have to look at those separately. There are exceptions with Chromebooks where the speed won't be necessarily so tied to the processor and the memory and things like that, because it's a much lighter operating system than Windows. So a Chromebook and Windows with exactly the same spec, a Chromebook's going to be faster. So it's worth considering that they're not always like for like if you're buying Chromebooks. But then Chromebooks often can't do more kind of serious tasks, and it's worth considering if they're actually compatible with software that you're looking to install in the first place. It's always worth reading the reviews. If I'm looking at a laptop, I'll search for the model number. So on the right hand side, I've just given an idea of where to find that on a case. So it's often on the bottom of the laptop. It will give you the model number of the one that you're using. So on the right hand side, it's the Lenovo B50-30. So if I type that in and typed in reviews, there'll be some reviews that'll pop up, and you can have a read through and just see what they think about the features there. If in doubt, you can also email the supplier of the software to find specs. So you could email Dragon support, for example, and just say, this is the laptop I'm thinking of getting. Does this compare with your specs? What would you recommend? And things like that. And depending on how helpful you are, you might get some useful information from that. You can also check your current spec of your laptop. So why this is useful is I might be running my laptop now and I can test it with a particular app and then see, well, if it's working on my laptop, what specification have I got, and will this work for a student? So I'm just going to show you what this looks like. So we're going to go on the top. First of all, we're going to be checking out our system information. So we're going to be hitting the Windows button and going to system information. This might be locked down if you're on a computer belonging to a college or an organization that's locked it down, but you can certainly do it on your own devices. So just stop this share. Just share my screen. Okay, so you should be able to see my whole screen now. So I'm going to hit Windows. I'm just going to start typing in system, and it already comes up with system information there. So I'm going to click on that. And this will give me the basics of my system information. Jack said you can get around it if it's locked by going on CMD and typing system info. Thanks, Jack. That's a good one. I didn't know that. Obviously, don't do that if your IT team don't want you to. I can't advocate for things like that. Um, but on this list here, once you're into there, you can go to your operating system name, and that'll give you the version of Windows that you've got. So I'm on Microsoft Windows 10 Pro. You can also go down to processor there, and it will give you a processor. So earlier when we were typing in the processor, if I typed in i5-10300H, that would tell me more about the processor itself. But I can also tell that it's 2.5 gigahertz and it's got 4 cores. Other things that we can look at here, probably one of the key ones is installed physical memory, RAM. We've got 8 gig of memory there. So that's how we can find those things out. Sometimes they'll be written on your case as well, so that's worth considering. But the other one that I'm going to go to is I'm just going to click on the File Explorer here. And if I go to this PC, which I'm already on, it will tell me devices and drives. So this tells me that I've got 14.4 gig free of 216 gigabytes. And some of that will be taken up by the system itself. So that's how to find out my storage and what I've got at the moment, which is very low, actually. I need to either upgrade that or add another hard drive to it, or clear some junk out. So those are the things that you can kind of find out for yourself on a computer, which are quite useful. And yeah, as I said before, you can always find the serial number of your laptop with that label, and then look it up and find out the specifications for it, and it will give you more detail than you might be able to find in these ways. You can also check your current performance, and I'm not sure actually if it will share on my share screen, so this will be interesting to find out. But if you hit Control-Alt-Delete and you go to Task Manager and then you look in the Performance tab, you can find out your processor, what it's running at currently, your memory, your disk, and your GPU, which is the graphics. And that'll just be a snapshot in time, and marked kind of on a chart, lots of different snapshots. So it'll be performed differently when different apps are running. So you can actually test it by running the app that you're testing. Is it using up all my processor? Is it using up all of my memory at the moment? That type of thing. So on the right-hand side there, you can see my processor. It's only using 4% of it. So actually not much being used. Whereas memory, I think because I had Chrome open with lots of different tabs, it was using up quite a lot of my memory. So I know then with my computer that actually my memory is probably a weak point there in that whole thing. Okay. Jess has added a little note here, just a note not to always rely on the label that comes attached to the laptop. I've had an experience where the organization changed the specs and left the label on. Oh, Jess, good one. I hadn't thought about that. Wow, that's really going to throw you there. Yes, that's a good point. And you cannot, sometimes the laptops themselves have a label that will be broken if you open the laptop. So you can often tell if someone's already changed something in the laptop. But yeah, good point, Jess. Thanks. So that's the end of the webinar. It's just been a real kind of whistle-stop tour of the essentials of what you've got with the specifications and how to match it up to a computer. So yeah, thank you everyone for listening. I'll keep the room open a little bit longer if you've got any questions or you want us to go through any particular specifications. But failing that, thank you everyone and goodbye.